Caloric restriction and fasting have emerged as two of the most promising non-pharmaceutical strategies for extending lifespan and improving overall health. Long before the development of modern medicine or biotechnology, nature itself hinted at the power of less is more when it comes to food. Across species, from worms and flies to mice and primates, reducing caloric intake without malnutrition has consistently led to longer lifespans, improved resistance to age-related diseases, and enhanced metabolic efficiency. As science deepens our understanding of the mechanisms behind this phenomenon, we now see a growing interest in applying these strategies to human aging and longevity, with early trials showing cautious but hopeful promise. At the core of caloric restriction is the idea that the body responds to lower nutrient availability not by shutting down, but by activating powerful survival pathways. These include improved mitochondrial efficiency, enhanced DNA repair, reduced inflammation, and a shift towards cellular maintenance over growth. One key mechanism is the reduction of insulin and IGF-1 signaling, pathways that are known to promote aging when chronically elevated. Another is the activation of AMPK and sirtuins, enzymes that sense low energy states and respond by increasing stress resistance and promoting autophagy, the body's natural recycling and repair system. These molecular shifts support not only a longer life, but a healthier one, with reduced incidence of cancer, cardiovascular disease, diabetes, and neurodegeneration. Fasting takes this concept further by introducing rhythmic, intermittent periods of low or zero caloric intake. Unlike continuous caloric restriction, fasting triggers metabolic changes in a shorter time frame, switching the body from glucose burning to fat metabolism and ketone production. These ketones are not only fuel efficient but also anti-inflammatory and neuroprotective. Fasting enhances autophagy, supports immune regeneration, and may even stimulate stem cell activity, helping to rebuild tissues and clear out cellular debris that accumulates with age. In animal studies, intermittent fasting, alternate day fasting, and time-restricted eating all show benefits similar to lifelong caloric restriction, but with more practical flexibility. Mice subjected to these regimens live longer, retain more youthful muscle and brain function, and show fewer age-related pathologies. Some studies even suggest that fasting may offer superior benefits by inducing periodic cycles of stress and recovery, which promote resilience and regeneration. Translating these results to humans, however, comes with challenges. Unlike lab animals, people live complex, varied lives, and lifelong caloric restriction is difficult to sustain without unintended consequences like fatigue, social disruption, or potential nutrient deficiencies. Nevertheless, human studies are underway, and the findings so far are encouraging. Trials such as the Caloric study have shown that moderate caloric restriction, just 10 to 15% less than normal intake, can lower markers of inflammation, reduce blood pressure, improve insulin sensitivity, and even slow biological aging as measured by epigenetic clocks. Intermittent fasting, particularly in the form of time-restricted eating, such as an 8-hour eating window, has gained popularity for being more manageable and socially acceptable. Early data suggests it can support weight loss, improve metabolic markers, and potentially enhance cognitive clarity, all without the stress of constant calorie counting. Periodic fasting-mimicking diets, which are low in protein and calories for 3 to 5 days at a time, also appear to promote many of the same anti-aging effects seen in animal models, including enhanced cellular repair and reduced cancer risk. What's most compelling is that these dietary interventions do not simply slow the aging process. They appear to target its root causes. By modulating nutrient-sensing pathways like mTOR, insulin/IGF-1, AMPK, and sirtuins, caloric restriction and fasting recalibrate the body's priorities, from growth and reproduction to maintenance and survival. In this way, the body is not only protected against disease, but equipped to function better, longer. Of course, these strategies are not suitable for everyone. Individuals with certain medical conditions, eating disorders, or very high energy needs should approach fasting and restriction carefully and under medical guidance. However, for many healthy adults, mild to moderate versions of these interventions could be a sustainable way to promote long-term health without the need for expensive drugs or complicated procedures. As human trials continue and our understanding deepens, caloric restriction and fasting stand at the intersection of ancient wisdom and modern science. They offer a simple, accessible tool that aligns with our biology, tapping into evolutionary survival mechanisms to delay aging, enhance performance, and increase resilience. If used wisely, they may become one of the most powerful strategies for not just living longer, but living better.